Oh yeah, here we go in one of the lesser known examples, but ones that sometimes are asked by college professors and AB and BC teachers. So here we have it. It says find the family of curves that is orthogonal or perpendicular to the family of curves described by the equation below. So you've got this family of curves, x squared plus y squared equals c. That's all of these circles here. Our goal is to find the family of these curves here that are perpendicular to it. So you see that it's perpendicular to it everywhere. So our goal is to figure out what's that family of curves. So how do we do that? Well, first things first. If you're perpendicular to something, then you know that you have perpendicular slopes. So what we're going to do is we're going to find the slope of this, dy dx. And then we're going to take the opposite reciprocal. Let's just do that first. That'll at least describe the slopes that are perpendicular to all of these slopes of these circles everywhere. That's our goal. So I'll take the derivative with respect to x, which is 2y dy dx on this part, and the derivative of a constant is 0. Then we solve for dy dx. I'll subtract 2x from both sides, and then divide by 2y. So again, all I did there is subtract 2x and divide by 2y. That's minus x over y. We've actually anti-differentiated this one recently if you did the earlier lesson videos. So minus x over y. That's the derivative of the circles. So that gives you the slopes anywhere along here. So maybe a slope here. Well, I want the slopes that are perpendicular to it. So what we do is we take the opposite reciprocal. We flip and negate it, if you will. So the perpendicular slope is going to be equal to the opposite reciprocal. The opposite of that is positive, and then it'd be y over x. So if we want the family of curves that have these slopes, now we're asked to solve this differential equation. You're essentially now being told that dy dx is equal to y over x, and that'll give you all of these curves. Let's see the magic. So now we're going to use our differential equation solving skills. I'll divide both sides by y, so I'll get dy over y, which is equal to dx over x, and we actually did one similar to this very recently. And we'll now integrate both sides with respect to y and with respect to x. That's ln of the absolute value of y equals ln of the absolute value of x plus c. We'll exponentiate both sides. Oh, yes, we will. The absolute value of y equals the absolute value of x times c. Remember, that's e to the c. And I go over why that is in an earlier video, so if you're asking why, check that out. Then the absolute value of y can be undone, and we're still left with c times the absolute value of x. That plus or minus gets absorbed into the c. And that's the family of curves. And sure enough, I'll highlight one for you right here. So let me get my handy dandy highlighter. And let's use a nice bright color. Let's look at this. That's basically the absolute value of x. Oh, look at this right here. Look at that curve. It goes down into there and then bounces up. There's your absolute value of x curve. But that c value makes them wider, or could flip them down, right, and have them go in the other direction. So that's the family of curves. And no matter where you look, you are perpendicular to the circle. Isn't that neat? So very important in the real world in terms of trajectories and how they're perpendicular to each other. Has a lot to do with centripetal force, a lot. And I'll just leave it at that. So very, very cool stuff. I'll see you in the exercises, but until then, stay awesome and be well. Peace.